Evaluating some exponential expressions can be incredibly easy. For instance, 2 to the 0 power, or any number raised to the 0 power, would just be equal to 1. 2 to the first power would be equal to 2. 2 squared would be equal to 4. But we're going to need to be able to rely on a calculator once we get into more complicated expressions to evaluate. Every calculator is a little bit different, but what you should be able to find is a log button which has 10 to the x power written up above it, and another button that says ln with an e to the x power up above it. Those are the two buttons that we'll want to make use of in order to evaluate these exponential functions. In the case of the calculator that I have pictured here, I would need to press the second key and then the log key. Since I'm pressing that second key first, I'm actually accessing that function up above the button, meaning what I'm actually accessing is that 10 to the x power feature. Similarly, if we were to press the second key and then the ln key, up above that we would see e to the x, which would allow us to evaluate exponentials with a base of e. What we can do is, in the case of the problems that we're given here, we have in the first two examples a base of 2. We can simply type in 2 and then use the exponent key on your calculator, which should look something like this guy here, and then type in 2.8 to get approximately 6.964. Similarly, we could type in 2, use that exponent key. On the calculator I have pictured here, we would press the second key and then the x squared key, which means we'd actually be inputting that square root, that radical feature that's up above it. Let me go back actually. What we would want to do is, no, I had that right. My own writing was kind of blocking what I wanted to see here. So up above that square root x squared button, we would have that square root function. And then we could type in 8 to get approximately 7.103. So we didn't need any special keys in terms of the exponential portion. But now for example 3, we need to take e raised to the 2.6 power. So what we'll have to do is access that e to the x feature by pressing the second key, the ln button, which means we're actually accessing that e to the x feature. And then we'll type in our value of 2.6 to generate approximately 13.464. Again, every calculator is a little bit different, but hopefully you can experiment with your own to find out how you would arrive at those same results. In example 4, we have one more case. Keep in mind, since this is e written to the negative 0.06 power, we could either evaluate that as is, or since we have that negative exponent, we could rewrite this as 1 over e to the 0.06 power. But either way, we should get approximately 0.942. In example 5, we're given a function f of x equals 4 to the x power, and we're first asked what is f of 5. So even though we're dealing with an exponential function, there's nothing different here about how we would approach this. We would essentially want to evaluate f of 5, which would mean everywhere we have an x in our function, we want to plug in 5. This would give us 1024, which would mean that our function has the xy coordinate pair 5, 1024. So we plugged in a value for x and generated an output for y. In part B, we're asked a slightly different question. If f of x is equal to 1/16, what is x? So that means we have 4 to the x power equals 1/16. We want to determine the x value that would make that true. So we know that 4 squared would be 16, which wouldn't get us quite to the answer that we want. But if we evaluated 4 to the negative second power, that would be 1 over 4 squared, which would be that 16 we're after. Telling us that x equals negative 2 would be the solution that would yield that function value of 1/16. and this corresponds to an xy value of -2, 1/16. In example 6, we have a similar question, but our function's a little bit more complicated here. In part A, we still just want to evaluate the function for x is equal to -1. Which would be the same thing as 1/5 plus 6, or 31/5. So these two values would correspond to the xy coordinate pair of -1, 31/5. And then in part B, we're again given a function value, and we want to determine the value for x that would give us that value, meaning we have 5 to the x power plus 6 is equal to 131. We can start off by isolating that 5 to the x power on one side by itself by subtracting 6 to the other side to get that equal to 125. So now what we need is a value that we can raise 5 to in order to get 125. 5 squared would be 25. 5 cubed would be that 125 that we're after, telling us that we want, in this case, an x value of 3, corresponding to the xy coordinate pair for this function as 3, 131.